Welcome to Everything Musical, and this is actually Pro Audio's first university class we're teaching. That's something. So we got Pro Audio Class 1. We're going to be covering live audio systems and components. Things we're going to be covering: power conditioners, mixers, signal processing, power amplifiers, speakers, cables, and connectors. Power conditioners. The main thing you're going to be looking for in a power conditioner is one of the most important parts of your system. Getting conditioned power is going to make everything blend together really well. It also protects your system. So for the Furmans are the ones that we have on display here. We're going to be pulling them out later, but you want to make sure you watch the spike and surge protection for them. So for the Furmans, they can actually handle up to 6,000 volts or 300 amps of pulses, multiple pulses at one time before giving out. You also want to look at noise filtering. For the Furmans, they utilize common mode noise cancellation using an isolation transformer with a center tap to cancel out any noise coming across the line. So really helps out with keeping noise out of your system also. The amperage ratings, these are rated up to 15 amps, and nowadays your digital amplifiers aren't going to have anywhere close to that. Digital amplifiers usually run like 1 amp, half amp, and produce a lot of power with that. So and they're smart and easy. So from that, we're going to move on to mixers and the difference between passive and powered. So you have different uses and situations where you would want to use passive and powered mixers. For passive, it's going to be better for most of your install purposes and allows for greater control of your signal. Powered is going to be better for mobility and convenience. You're basically going to have, on a powered amp, you're going to have your amplifier, or a powered mixer, you're going to have your amplifier built into your mixer, so it's one and the same. If one part goes out, you lose everything. That's another downside of getting a powered mixer. Another thing you need to focus on are your channel needs. When you're picking out a mixer, you really want to, well, if it's going to be a permanent install, you're going to want to give yourself room to grow. Say you're in a church and right now you only have 3 microphones and you're plugging your clavinova into it and you might mic a drum. Well, 6 channels would be good for that to start out with, but say you end up wanting to throw a couple choir mics into it, or you have another vocalist that wants to bring their mic in, or you want to plug a computer into it, anything like that, you're running out of channels at that point. So if it's a permanent install, it's better to just go with something you can grow into than to limit yourself. Now for more mobile purposes, it's okay. Say if you have a 3-piece band and all you're going to have is a guitar plugging into it and a mic. 3-channel, 6-channel mixer would be perfect for something like that if you know you're not going to be growing out of it. Now we're going to talk about additional features that can be offered. So each mixer comes with additional features, or the lack of these features, but they can have anything from PV's Cosmos system, which is kind of like a play on a sonic maximizer, but different. They've actually copyrighted that. And then you have compressors that can be on each channel of your mixer. EQ, you can have your 3-band EQ on each channel and have like a 6-band, 8-band, 10-band EQ for your mains, the outs, the post fader outs. You can have effects that are selectable on each mixer. Phantom power, that's pretty much included on any mixer now. And that's what's going to be your 48 volts powering your condenser microphones. MIDI throughput, that's important for some people. USB interface, being able to have your live audio mixer also be an interface to be able to record on your computer or a separate system. That's important to some people too. So it's important to kind of look at the features that the mixers offer and tailor it to your needs. We'll be getting into signal processing. So another important thing about your passive mixers were the greater signal control. In order to have post-mixer control, you cannot have your amplifier built into your mixer. So with a powered mixer, that's it. Whatever you have on that mixer is the control, the effects, that's all you get, whatever's on that mixer. With a passive mixer, you can actually have different equipment in line prior to your amplification. So you can have a passive mixer with an EQ, 31 band 2-channel EQ, something like that, or sonic maximizer, any type of signal processing. It would be post-mixer, pre-amplifier. Some of these signal processing that are offered. Sonic maximizer, actually we have one out here on display, BBE offers, and what that's going to do is it's going to boost your highs when your mids reach a certain threshold. So say a mid-range, you get a spike in your frequency, the decibel level of your frequency, and then your highs are going to get drowned out by that. So that what it will do is boost your highs to kind of compensate for that and level it, as well as whenever all that's taking place, it kind of cuts out some of your tones on your bass end, and it adds those back into, and you can control how each one of them sounds, and it just kind of cleans up and levels everything out, almost like a compressor limiter, but not quite. And then you've got equalizers, or EQ. They come in a wide range of options. The one I prefer is for the best control over your system is a dual band 31 or dual channel 31 band EQ, and that gives you 31 different bands that is breaking the frequency, the audible frequency spectrum into, so you can control it more precisely. With the 3-band EQ, you're either not going to have enough control, or when you do try to minimize some feedback, you're actually minimizing a lot more of the frequency range than with a 31 band EQ, where you can pick a specific frequency range and just get that out altogether. So for feedback purposes and live audio with churches and things like small rooms, depending on the construction of the rooms, EQs are essential, especially when you're talking about condenser microphones for like choir mics or podium mics. When you would have that high frequency feedback, most of the time it's high frequency, you can control that a little better without drowning out the rest of the frequency band as well. You also have effects, and effects can range from reverb, delay, echo, compressors, limiters, another parametric EQs. These are all effects that are provided on either separate components or the mixers. Some of them are included on your amplifiers now if you get DSP options, which is just digital signal processing. It's offered all over the place on all this equipment now, so you will not be without. Another big thing, crossovers. So what that's going to do, a crossover is basically going to allow you to have high pass or low pass to be able to separate your highs and your mids from your lows. So if you have a sub amp that is just supplying signal to your subs, you don't want your highs and your mids going to that also, so you can separate that. You can cross over the point where the signal is what part of the signal is going to that amp. It really cleans up the sound, and also whenever you have all your lows coming off of your mains, it cleans up your mids as well, because that speaker's not having to process the lows with it. So it just makes everything sound cleaner if you have a main and you have it crossed over at the right frequencies, and you can play around with it and kind of get your feel for what frequency you want, what decibel level you want it to be going. Alright, so that's signal processing. Next we're going to be going into our power amplifiers. Important things to look at when you're looking at power amplifiers. One of the most important things, wattage. So the wattage that a power amplifier provides is going to be based on the load that the amplifier has on it. It's all about resistance. You can look at most power amplifiers and it'll show you a chart of what wattage you're going to get to your speakers at what ohm rating, resistance rating that you have, which is another thing to look at, your ohm load ratings. And that's basically saying however many speakers you put on one channel, it's going to lower that resistance on that channel, and that's going to rate how much power you're getting from that channel. So, and it'll show you on most amplifiers, it'll show you what the continuous and what your and continuous program and peak wattages would be for that channel with the different ohm ratings. They also offer additional features. So if you wanted to have your amplifier with a delay on it, or DSP in general, you can have delay, EQ, crossovers built into it. Like for instance, this IPR doesn't have it, but the IPR 3000 we have down here does come with a model that has, or used to come with a model that has DSP on it that allows you to set a crossover on the amp. So you no longer need a crossover at that point. You just say, this is going to be my amp for my sub cabinet, and I'm going to set everything below 250 to go to this. And then it'll just take in your input and cut out the rest of it. It doesn't even take the rest of the signal. It just takes what you tell it to. So, all right, now for speakers, you also have a passive and a powered version of these. Typically, it's better to have your amplifier as close to your speaker as possible. That being said, I'm not a fan of having your amplifier built into mixer or speaker, just because of the fact if you lose your amp, you lose your speaker. That's it. Like with your mixer also, you lose your amp, you lose your mixer. So there's benefits to having it. I still use them even though I don't like the concept of it, just because they're super easy to be able to set up somewhere and run a signal cable to. And that's it. Like, you can have your main system and then have, say, someone wants a signal ran into another room just to have background music in there, and you can run an auxiliary cable or an auxiliary send to a powered speaker in another room and have it completely separate from your main line. So there's good and bad behind it. Passive, they're just a speaker cabinet. They usually have specific crossovers built into the cabinet. That way your tweeter and your speaker have the cutoff for your highs and your mids. But there's not much to them. Your amplifier is what's going to be supplying the power to your passive speakers. Size. The biggest thing with size here, you're going to want to look at the area that you're trying to get coverage for. The bigger the speaker, the more air the speaker is going to move. You'll have a higher SPL. For bigger areas, you want a bigger speaker to be able to produce that sound further. So you don't necessarily need that in smaller areas, but the bigger your speaker, the cleaner that your lows and your mids are going to sound too, because you can produce more frequencies on that cone. So the cone size makes a difference in everything. But back to that with the wattage matching, you want to make sure when you buy a speaker, it'll say on there usually like, this is 2,000 watts. Now I'm pretty sure that that's peak, that it's not program, but you want to look at the actual specs of your speaker to see what your continuous is, because continuous is going to be the wattage that you're running it at for the course of your performance. So if you're going to have 1,000 watt continuous, you need to make sure on your amplifier, depending on how many speakers you hook up, that you're actually getting 1,000 watts for that, or you're going to be underpowering your speaker. Or if you're drawing too much power, you could be overpowering your speaker or overpowering your amp. If you're maxing out your amp, you don't give it any headroom, it's going to cause issues with distortion, line noise. It's not good at all. You want to make sure you have headroom, and that's usually what your program power is going to account for. So if you look at a speaker and it says continuous, this is what you're going to be running at. Your program's going to be what the manufacturer recommends for headroom, and then your peak is going to be burst, what your speaker can handle at short amount of time. With that being said, you want to look at impedance matching with your speakers too. So most of your cabinets that are, it doesn't matter with powered because your amplifier is built into it, so they match that for you. But with most of your passive 15-inch speakers, 12-inch speakers, 10-inch speakers, they are rated at 8 ohms. That being said, you want to hook or match it to your amplifier. So if you have a 3,000 watt amp and I'll just use it a number. This isn't necessarily what this one provides, but if it provides 570 watts on a 8 ohm load, then it's probably gonna double. Usually if you add another speaker, it's gonna get close to doubling the wattage. So you'd go from 570 to maybe like 925 by adding another speaker onto one channel, which you're taking an 8 ohm speaker, paralleling another 8 ohm speaker, which drops the ohm load to 4 ohms now. Anytime you add two of the same numbers and resistance together, you're having that. So two 8 ohm speakers would be a 4 ohm load. Cables. This is also important. Big thing to look at, gauge. For most of your signal cables, you're going to be running 16 gauge for the most part. And something to note on this, the smaller the number gets, the thicker the cable gets. So most people get that backwards. The smaller the gauge, the thicker the cable. So with a 16 gauge cable, it's going to be most of your signal cables that are used for basic connectors and anything that doesn't require a powered signal. You don't need a lot of power for signal cable, so it's typically you don't need a lot of cable. The thicker cables, like 14 gauge is what I recommend for most speaker cables, because you are sending a powered load over them. But once you get down to like 100-foot cables, or up to 100-foot cables, I recommend going down to 12 gauge, just because you don't have as much loss over long distances with the thicker cables. But it's really important that you match the right gauge to your needs, because you'll know if you don't have the right gauge. Say you get a 16 gauge speaker cable and you run it 100 feet, you're putting 7,500 watts through it, that cable is going to heat up. You'll feel it. You know it's wrong when it's heating up. Then we'll talk about shielding. So most of your signal cables are going to have shielding associated with it. So you'll have 3 conductors. You'll have the left and right, if it's a stereo connector, and a shield that you can hook up for a ground. Speaker cables typically aren't shielded. You'll have just 2 conductors. It'll be the hot and the ground. Solid versus stranded. Solid is not going to be used much in pro audio at all, unless you're talking about rebuilding crossovers or something like that, where it's going to be something that's not moving around a lot. But all your cables that you use for pro audio are going to be stranded, and it just increases your tensile strength of the cable and also the surface area of the cable. If you have 100 stranded cables side by side as a conductor, it's going to have more surface area for the electricity to transfer over than one solid piece of metal going down the cable. So it increases your the distance you can go with that too, especially with shielding on it. Alright, conductors, that's another big part of it. Unless you're biamping, you typically don't have more than 3 conductors, and your 3 conductors are going to be usually used for signal cable. 2 conductors would be used for your speaker cable. The conductors are just the bundles of cable inside that are going to be transmitting data through the cable. So the actual metal inside your cable. 3 conductors, you're going to have left, right, ground. 2 conductors, you're going to have left and right on one, and a ground for your, or left on one and right and ground on the other. For the most part, you're going to have it broken down into your signal connectors and your speaker connectors. Typically, you're either going, I didn't even bring one up here, but speak on, which is the newer standard for speaker cables. They're a lot better. They don't just pop out if you get any SPO in your cabinet that's going to really force out they can force out a cable. They bolt in and lock. You just push it in and lock it sideways, and they're really sturdy, especially the way that they clamp down around the cable when you're putting the connector on the end of it. Other than speak on, you have your 1/4 inch TS. and that's just signal cable and a ground. So they use bare wire also. On most of your amps you'll have bare wire connectors where you can actually unscrew it, like home audio stuff. You unscrew it, put the bare wire in, and tighten it down. Now on top of that, for most of your pro audio amplifiers, you can do the same thing with this. It's called a banana clip. So you unscrew these, put the bare wire in, screw them back down to tighten them, and now you can take this same thing and plug it into most of the adapters on the back of your amps that you would technically tie the cable into, which makes this plug and play now. It's bare wire plug and play, so it keeps it more, well, it's more durable. You don't have to worry about the connectors breaking off and your wires splitting out every time you try to take it apart. It's just much easier. Just toss this on your cable and plug it straight in. So that would be speaker. The TS, which is your tip in your sleeve, is going to be signal and ground, and then whichever way you wire it. Actually, this one says ground on the side here. It's got a little tab, so you want to wire your ground to the ground, and then plug it in the same way it tells you. For signal, you have crazy amounts of options. TS you can still use for signal. TRS, which is a tip, ring, and sleeve, which breaks stereo. Your tip is going to be left, your ring is going to be right, and your sleeve is still going to be ground. It just gives you another conductor to transmit over. You have XLR, which is the same. If you look at inside of there, you got 3 pins. One's going to be tip, one's going to be ring, and one's going to be sleeve. The important thing to know about these are the males and females. Specifically with XLR, people get this confused a lot. They think because this one is what you plug into a hole, this is male. That's wrong. They have the 3 holes there. The 3 conductors are what you want to look at when you're looking at male and female. The 3 conductor holes is female. The 3 pins for the conductors are male. So this is actually the male connector. Now, RCA we have here, male. That's pretty easy to figure out for most people. And you have female on the back end of this. So got, yeah, that's pretty much it. Anatomy covers that. And then you have a difference between balanced and unbalanced. Kind of focused on that a little bit when we were talking about DMX cables, the shielding on the cable. So a balanced signal is going to allow that shield to pick up noise over the distance that it's being traveled, and then tie it into your ground and reverse it to cancel it out, reverse the polarity of it to cancel it out. It is only able to do it if both pieces of equipment take balanced cables. So your equipment has to have a balanced signal input for it to use that cable correctly. You can use an unbalanced cable and a balanced signal, or a balanced piece of equipment, or vice versa. It's just whether or not you have a balanced input and a balanced cable is going to determine whether or not you'll have that noise cancellation on that cable. Balanced has no shielding and is more susceptible to line noise, which is a bad issue for pro audio. Adapters. We have adapters for just about anything. What this does, it's called a stereo breakout cable. So it takes a TRS input. This is a TRS female, which would be part of the TRS male. You have TRS that goes into this and takes the tip in the sleeve and the tip, or the ring in the sleeve, and separates it into 2 mono signals. So you're able to have a stereo input or stereo left and right out, mono out on, say, a PV6 mixer. You have 1/4 inch mono outs. Now you can take both of those, put them into a TRS, and have one cable ran out to one speaker if you wanted to, and you're not losing left or right. You're able to keep both of those. We also have XLR splitters. All this is doing is saying I can take one input and send it to do different things. This is really handy on amplifiers. If you have a left out and you want to use that left just for your sub amp, You can have left out XLR plug into this go into both channels of your sub amp. Now you're having the same signal go into both channels of your sub amp, and you can have separate speakers that are utilizing that signal. So it kind of expands how you use things. Also, if you wanted to have, I don't know why you would want this, but say one mic into two different channels of a mixer, or the same signal at all into two different channels of a mixer, you could do that. They also make these in reverse, so the worst, having two mics plugged into one channel of a mixer. When you run out of, that's not good to do, because now you don't have, say you have two mics plugged into one channel of a mixer, and that channel has one EQ, the 3-band EQ. Now you can't just say one mic is for a male and one mic's for a female. They're going to be EQ'd differently. But you can't do that because you're limiting yourself to one channel. So now you pick one general EQ and hope it works for both of them. Alright, do we have any questions or answers? Or questions I can answer? Thank you for watching our introduction to Pro Audio and fundamentals of sound. And stay tuned for more to come with Pro Audio and lighting.